All right, so if you were in class today, you already got these examples. This is from 9-5, completing the square, but if you weren't in, or I went a little too fast, or you just want to go back and watch it again, I'm doing 36 through 41 from page 400 if you want to follow along in your book. But I'm going to do it on a separate piece of paper just because I want to make it really clear what I'm doing with each step. So let's see. Oh, and I wrote this down wrong. It was actually, when I did it with the first class, I wrote positive. Let's see. It's y equals x squared plus 4x plus 3. So the first thing we want to do is just give ourselves some space to add in whatever completes the square here. So I'm going to put a little space on this side. And I've got x squared plus 4x. Oh, I put plus 3 again, and it's minus 3 in the book. Okay. Minus 3. Give yourself some space for whatever your c value is. And then what I think makes it a little less confusing for you guys is start your vertex form right underneath. All right. So we take half of b and put it here. Half of 4 is 2. And then square that and put it here. We added 4 on this side, so we're going to add 4 on this side. So now I want to cancel out the plus 4 here because I just want a y equals. So I'm going to do minus 4, which means I got to take minus 4 on the other side. So that means y equals x plus 2 squared minus 7. And my vertex, remember, my x is always opposite. It's negative 2, negative 7. Um, 37. Y equals x squared plus 12x plus 27. That's what we're starting with. I'm going to give myself some room. And I need some room over here to add. And then I'll start my vertex form here. Oh, and this is plus because this is plus. If it was minus here, it would be minus here. And this number would still be positive. Plus 27. So we take half of b, half of 12 is 6, square it. 6 squared is 36. So I also add 36 here. Then I'm going to subtract 36 on both sides. So y equals x plus 6 squared minus 9. And my vertex is at negative 6, negative 9. All right, 38, we've got one more of just the regular, and then I'm going to do some with the greatest common factor. Y equals x squared, minus 6x plus 12. And at this point, I would want you to stop, pause, try doing this one on your own, and then start the video back up and see if you got it right. X squared minus 6x plus 12 x minus squared plus 12. Okay, half of 6 is 3. 3 squared is 9. See, and it's a negative 3 because this is negative 6. But if I did negative 3 times negative 3, it would give me positive 9. So it's positive 9 on both sides. Subtract 9 here. Subtract 9 here. Y equals x minus 3 squared plus 3, and my vertex is at positive 3, positive 3. Oh, you know, I'm going to grab another piece of paper. Because I know when I'm writing through the other side, sometimes it gets a little, you can see what I wrote on the other side and it makes it harder to read. Okay, so 39 is not 1. All right, I'm going to go to 40 because I want to show you a couple of those greatest common factor ones. They work a little bit differently. Just one little extra step we got to put. 3x squared minus 6x minus 2 is what we're starting with. So now we have a 3 here and a 6 here. So these are both divisible by 3. So I can divide the 3 off and do this. If I couldn't, then there's no way to complete the square to solve it this way. You would have to use the quadratic formula. So look, 3x squared minus 2x. This is 3 times x squared is 3x squared. 3 times 2x is 6x. Okay? Give yourself that room there. Minus 2. And then give yourself vertex form. X minus squared minus 2. So we set it up the same, but I divided off the 3. Then you take half of 2 is 1. 1 squared is 1. But I don't add 1 here because look, the value of this 1, you actually multiply it by 3. So this is actually adding a value of 3 to the equation. So I need to add a value of 3 to the other side and then subtract it. When I actually first started doing quadratics, I would add the 3 and subtract the 3 in the same side because they cancel each other out, whichever way you like to do. If that doesn't make sense to you because I've been doing it one way so long, then just don't listen to me. All right, so we subtract the 3 and we get 3x minus 1 squared minus 5. This does not change my vertex. This just changes how fast my line goes up. The slope of my line. Instead of going up 1 over 1 for the first dot, it'll go up 3 over 1. And my vertex is at 1, negative 5. I wanted to do something with this just to show you how to check these. So remember, when we go to graph a quadratic, I like to start with where's the vertex? Because if I know where the vertex is, then I can easily do a function table and find the other points. So if I plug this in, I should see that it's actually the vertex. And I'm going to use my original, not this equation down here that I came up with. Use the one that was in the book or on the test. Don't use the one that you changed. Check your answer with the original equation that they gave you. Okay, so I plug the equation into the middle of my function table, and I put 1 as my middle x value because the vertex is the middle of my quadratic. So 1, 2 and 3, 0 and -1. So now I should see it going, it's a positive slope, so it should be going down, 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 and right here, stop and go back up. And I should see the reflection right through here, right at the vertex. So I plug in my x values. 3 times -1 squared minus 6 times -1 minus 2. Again, how I plug things in with the parentheses. Otherwise, you might mistake this as 6 minus 1, or you'd have to put the times or whatever. This makes it a little easier. All right, 1 squared, or -1 squared is 1, times 3 is 3. -6 times -1 is +6. So this is 3, this is 6, that makes 9. 9 minus 2 makes 7. 3 times 0 squared minus 6 times 0 minus 2. 0, 0, -2. Then 3 times 1 squared minus 6 times 1 minus 2. This is 3 minus 6 is -3, minus 2 is -5. 3 times 2 squared minus 6 times 2 minus 2. 4 times 3 is 12, minus 12 is 0, minus 2 is -2. And 3 times 3 squared minus 6 times 3 minus 2. 9 times 3 is 27, minus 18 minus 2. 27 minus 18 is 9. 9 minus 2 is 7. See, it's perfect. We've got, it goes down, hits -5, right where we said the vertex would be at 1, -5, and then it goes back up, and you can see it's a perfect reflection. So if you want to check and make sure you got the right answers, or if you want to make sure you're doing things right, that's how you do it. All right, I'm going to do one more example with greatest common factor. Question 41 is 2x squared minus 20x plus 35. Divide the 2 off of here. So 2x squared minus 10x. Oops, I didn't give myself some space. Plus 35. And I need some space over here. And I need vertex form down here. This is minus squared plus 35. I take half of -10 is -5. -5 squared is 25. So I add 25 over here. Then subtract it. Ooh, I almost made the same mistake that I've been telling you guys not to make this mistake. This is 2 times 25 is 50. So I subtract 50 on both sides. All right, so we get y equals 2x minus 5 squared, and 35 minus 50 is -15. So the vertex is at 5, -15. All right, and see how easy it is to make that little mistake right there? Go back and check your work after you're done and make sure that, like, if there's a greatest common factor, that you didn't make that mistake. Just like when we're factoring regular quadratics and you go through the whole box method and can't figure out what happened, why it's not working, it's that greatest common factor. That is the thing that messes up quadratics every single time. All right, I hope this helped, guys. Have a good night. And if you have any questions, make sure you reach out.